We've reached the last step of solving a problem using a Karnaugh map. And that last step then is to write an equation based on the groups that we've just set up. So we're going to go back and relook at the 4 examples that we saw in the previous video. And what we need to do in each of those is look at the groups and determine what is true about the variables for every cell within a group. In other words, determine what is common or what is the same about every cell within a group. You know, I could look at one group of people and say, oh, you're all very tall. Or I could look at another group of people and say, oh, you're all female. Or I could look at another group and say, oh, you all belong to the same fraternity. And so I can identify common characteristics among people. I can also identify common characteristics among cells of a group. And so here, if I look at figure 11, which is just a revisiting of figure 7, I see that there are 2 groups. Now, each of those groups is going to form a product term. So the first group, I'll look at the vertical group here. So this vertical group belongs all to the first column. And what's true about every cell in the first column? They all have A equals 0. And since they all have A equals 0, that's what's common about every cell in this group. Do they have anything else in common? Well, no, because B equals 0 for this one and B equals 1 for this one. It'd be like looking at that group of women and saying, oh, some of you are Cubs fans and some of you are White Sox fans. You don't have that in common, but there are other things that you do have in common. So we have here only that A equals 0 for this group. And then for B equals 1, this bottom row right here, it has every cell in that group, which is only 2 cells, granted, but every cell in that group has B equals 1. Now the left-hand cell has A equals 0, and the right-hand cell has A equals 1, so it does not have those in common. But they do both belong to the bottom row, and so therefore they both belong to B equals 1. So for A equals 0, that's going to correspond to a product term of A bar, and for B equals 1, that's going to correspond to a product term of B. And so when we OR those together, because of course we need to cover both of the groups, so we're going to OR them together, we get F equals A bar or B. Now, being able to write an equation from a Karnaugh map, that's an extremely valuable skill. So I would encourage you to practice. Maybe you could fill in a Karnaugh map and have a friend do it, or you could fill in one and do it for yourself. We're also going to get a lot of practice with examples in this lesson as well. Here's figure 12, which is a revisiting of figure 8. You can see here that we had 2 groups. The first group, this is an interesting one. Both of these cells belong to the top row. Therefore, they both have C equals 0. But they also both belong to the left half of the table, and therefore they both also have A equals 0. You'll notice that both of these 2 columns have A equals 0, and so therefore, what's true about both of these cells? A equals 0 and C equals 0. Or as we could write it as a product term, not A and not C. Over here in the 4th column, these 2 cells belong to the 4th column, so they have A equals 1 and B equals 0, or written as a product term, A and not B. And if we were to OR those 2 groups together, we would end up with the expression not A and not C, that's the first group, or A and not B, that's the second group. Now let's flash back up to figure 9. I won't repeat it again. We're going to go back up to figure 9 so we can see what's going on there. In this case, remember, this is the one that had the wraparound grouping. And so if I look around at the wraparound grouping, well, it does not have C in common because some of them have C equals 0 and some of them have C equals 1. It does not have A in common because half of them have A equals 0 and the other half have A equals 1. But what they do all have in common is that B is equal to 0. So B is equal to 0 in both of those cases, in both of those columns, and so therefore the product term that represents that group is B bar. So not B, or B bar represents that group. It turns out that's the only group in this case. Because there's only one group, we don't need to have an OR function, so it's just F equals B bar in this case. That's a great example of a place where the fewest groupings really reduces the complexity of the logic. And then let's look at writing an equation for this K-map as well. Let's look at this first vertical grouping here. That belongs to the first column where A equals 0 and B equals 0. So we get not A and not B. This first row corresponds to C equals 0 and D equals 0. So that's not C and not D. And then down here, this third row corresponds to C equals 1 and D equals 1. So that is C and D. So not A and not B, or not C and not D, or C and D is the expression that we would have for that Karnaugh map, and there's the equation right there. So that's all there is to K-maps. You have to draw the K-map, you have to fill the K-map, you have to group the K-map, and then you have to write the equation from the K-map. 4 unique skills, no one of which is very hard, and all 4 of which you have now seen. You have enough information now to go to do the example of writing a Karnaugh map equation. But then I've also given you another example, which is the Karnaugh map start to finish. I just wanted you to see a full example without being interrupted, going from start to finish so that we could see going from the truth table to the minimized logic function.